Switching gears again. What if we had something time like this? 1/7 cubed, 1/7 to the third power. Well, we can use what we know about exponents to expand this. Raised to the third power means times itself a total of 3 times. Now here we're multiplying. We can multiply across the top. We can multiply across the bottom. Look at what we have. 1 times 1 times 1 is 1 cubed. 7 times 7 times 7 is 7 cubed. So these steps here, we don't really need. We're always going to have this little shortcut. So I'm going to write it again. 1/7 cubed equals what? It means 1 cubed over 7 cubed. And then at that time, we still need to expand it so that we could do the work. But hey, we didn't have to write 1/7 times 1/7 times 1/7. That saves us writing a fraction a couple of times. It's kind of a shortcut. But it's definitely how we should think about a fraction raised to a power. It's going to wind up being the same power given to the top and the bottom of the fraction. 1 times 1 is 1 times 1 is 1. 7 times 7 is 49. 49 times 7 . You get a final answer of 1 over 343. What about this one? Six sevenths squared. That's going to be 6 squared over 7 squared, which is 36 over 49. What's the other way to think about it? Well, it means 6/7 times 6/7, which would be 6 times 6 over 7 times 7, which is 36 over 49. This and that both lead to 6 times 6 over 7 times 7. Squaring a fraction can be thought of as either writing it all out, fraction times itself however many times the exponent is there, or giving the exponent to the top and bottom, which still expands it out. Either way, the only answer here is 36 over 49. Another one. 4/9 squared. That's 4 squared over 9 squared. That's 16 over 81. Or that's 4/9 times 4/9. That's 4 times 4 over 9 times 9. That's 16 over 81. It's time to PEMDAS. It's time to use order of operations to solve, to evaluate things that look like, I'm so sorry, this. 5/16 cubed times 4/5 cubed. We've come a long way since 5 plus 9. We've come a long way from this is how you pronounce this number. We've come to 5/16 cubed times 4/5 cubed. Order of operations says deal with the exponents first. So this is 5/16 times 5/16 times 5/16 times in the middle. And this is a 4/5 times 4/5 times 4/5. I implore you to write out these steps, because if you just start multiplying it out and going, okay, 16 times 16 is some huge number, and then that times 16 is some huger number, and then you get 125 on top, and you have that fraction. Write it all out, because look what's going to happen. We're multiplying all these fractions times each other, because this is times, there was times in the middle, times. Let's start canceling. 5 on the top with 5 on the bottom, gone. 5 on the top with 5 on the bottom, gone. 5 on the top with 5 on the bottom, gone. 4/16 divide them both by 4, that's 1/4. 4/16 divide them both by 4, that's 1/4. 4/16 divide them both by 4, that's 1/4. What do we have? Nothing but ones on the top, because when we canceled the 5s, those all became 1s. Nothing but 1s on the top means 1. Over, we just have 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. 1/64 is the answer. And if you multiplied it all out, you'd get huge numbers, and you'd be responsible for reducing it all the way down to 1/64. So that's why writing out your steps is important. It's the easiest way to do these. Don't make these harder than they have to be. Why did I start talking about order of operations and then stop entirely? Well, because once we took care of exponents, it became all multiplication. So we just multiply at that point. Had this been plus, we would not have been able to cancel. We wouldn't have been able to cancel one single thing, because the plus would have separated it into this group of multiplication that would be done on its own, and then this group of multiplication that would have been done on its own. Then we would have had to add those two. And I'm sure we're going to get an example like that eventually. But in the meantime, we're going to keep everything exponents and multiplication. Next up, let's look at 5/6 times 2/7 squared. What is squared here? Just the 2/7. At any point then, should you be squaring the 5/6? No. So how do we write this out? This is 5/6 times 2/7 squared. 2/7 times 2/7. Order of operations says take care of the exponent first. Writing it as its multiplication form is taking care of the exponent. Now we have all multiplication. Can we cancel anything? Yeah, we can cancel a 2 and a 6 by dividing them both by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So we have 5 times 1 times 2 over 3 times 7 times 7. 5 times 1 is 5, times 2 is 10. 3 times 7 is 21. 21 times 7 is 147. 10 over 147 is the answer. Next up, 1/7 plus 1/4 times 1/5. Now we do have addition mixed in. No exponents, so small miracles. What do we do first? PEMDAS says multiplication before addition. So we are going to do this multiplication problem, 1/4 times 1/5. Bring down everything else, 1/7 plus. And when we multiply, do we get a common denominator? No. Oh, that was snappy. No. Don't ever get a common denominator when you multiply. Okay, so this problem, 1 times 1 is 1. 4 times 5 is 20. So now we have 1/7 plus 1/20. Now we get a common denominator. And what is that? Well, 7 is just 7. 20 is 4 times 5. 4 is 2 times 2. So 2 squared times 5. Every base we have raised to the highest power shown. Common denominator 140. Seven times what is 140? That was 7 times 20. 1 times 20 is 20. 20 times what is 140? That's times 7. 1 times 7 is 7. We get 27 over 140, which doesn't reduce. Let's do another order of operations problem, and I'm going to complicate it up this time. 1/8 times, in parentheses, the mixed number 2 and 11/12 minus 1/4. Order of operations says work inside the parentheses first. Inside the parentheses, we have a mixed number subtraction problem, and we spent a lot of time on that before the break. So off on the side somewhere, you're going to go 2 and 11/12 minus 1/4. You know you're going to need these both to be 12ths. 4 times 3 gets us 12, so 1 times 3 gets us 3. 2 minus nothing is 2. 11/12 minus 3/12 is 8/12. 2 and 8/12 reduces to 2. Divide these both by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So 2 2/3, not the final answer, but that's the answer to this subtraction problem. So back to where we started. Inside the parentheses, we have 1/8 times 2 and 2/3. How do we multiply when we have mixed numbers? We have to change the mixed number to an improper fraction. So this is 1/8 times 3 times 2 is 6, plus 2 makes 8/3. 1/8 times 8/3, the 8's cancel, and we're left with a final answer of 1/3. That's the only one I'm going to throw a mixed number in. When you see a mixed number, though, treat it as you would in the context of a mixed number problem. Next up, 4 times, in parentheses, 1/2 plus 1/3 plus 4. Order of operations says work inside the parentheses first. 1/2 plus 1/3 needs a common denominator. That's going to be 6. 2 times 3 is 6. 1 times 3 is 3. 3 times 2 is 6. 1 times 2 is 2. Finishing up the addition. 4 times, what do we have left in the parentheses? 3/6 plus 2/6 is 5/6. We still have our times 4 in front and our plus 4 on the back. Order of operations says we do this multiplication before addition. Remember, when a number is right up against a parenthesis, that means multiply. So how do we multiply this? I'm going to go ahead and move it to the top so I have more room. I'm just going to rewrite it. No changes. You'll just keep going underneath. Paper is more forgiving than a dry erase board of this size. Well, when we multiply, 4 is 4 over 1 times 5/6. We can cancel 4 and 6. Both divide by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 times 5 is 10. 1 times 3 is 3. So we have 10/3 plus 4. And we know 4 is 4 over 1. When we add, we need a common denominator. Both of these will be over 3. 10/3 therefore doesn't change. 1 times 3 is 3. 4 times 3 is 12. 10/3 plus 12/3 is 22/3. No reason to change this over to a mixed number. 22/3 is our final answer. And you might be saying, what do you mean? There's a mixed number right there, 4 and 5/6. No, this is 4 times 5/6. Mixed numbers are 4 plus. 4 plus 5/6. We never had a mixed number in this problem, so we don't need it for the answer. Next up. In parentheses, 2/3 minus 5/9. On the outside of the parenthesis, a square, a second power. Order of operations, PEMDAS puts parentheses before exponents. So we have to work inside the parentheses before we take care of the square. We cannot square first. So inside the parentheses, we're subtracting. We're going to need a common denominator of 9. So the 5/9 doesn't change. Everything else is the same, but we need to change 2/3 to an equivalent fraction. 3 times 3 is 9. 2 times 3 is 6. Continuing in the parentheses, 6/9 minus 5/9 is 1/9, and now we're squaring the 1/9. 1 squared over 9 squared. That's 1 times 1 over 9 times 9. Our final answer, 1 over 81. Another one. One-fourth times 1/5 plus 1/2 times 1/10. Order of operations says multiply before adding. So here's a multiplication problem. 1/4 times 1/5. 1 times 1 is 1. 4 times 5 is 20. Copy the rest down. We would skip the addition because we have to do this multiplication now. So copy down the 120 plus 1/20 plus. And then 1 times 1 is 1. 2 times 10, that's 20 as well. 1/20 plus 1/20 is 2/20, which reduces to 1/10. Let's take a look at 15/16 plus 14/15 divided by 5/3 times 25/4. This is going to require a closer look at PEMDAS again. And the parentheses and the exponents, they're not in play here. But remember, multiplication and division is one step left to right as we come to it, as is after that addition and subtraction, left to right as we come to it. So do not go, M comes before D, so I need to multiply these first. Because if you do, you're going to get the wrong answer. It's just as wrong as adding first. You'll get two very different, very wrong answers. So since the division comes before the multiplication as we go from left to right, the division comes first. So we write down 15/16 plus, how do we divide two fractions? Keep the first, change division to multiplication, and then flip the second, 3/5. Don't forget, copy the rest down. Now, don't go ahead and finish this because it's a multiplication problem now, which means we have a string of multiplication, which means we can cancel where it's able to be done. 14 and 4 can both be divided by 2. 14 divided by 2 is 7. 4 divided by 2 is 2. 25 can cancel with either of these. I'm just going to go ahead and say 25 and 5 can both be divided by 5. 25 divided by 5 is 5. 5 divided by 5 is 1. So carrying out the multiplication, we'd have 7 times 3 times 5 over 15 times 1 times 2. I'm going to go ahead and write your next step up top. We just keep carrying this 15/16 plus down. And we'd have 7 times 3 is 21 times 5 over 15 times 1 is 15 times 2. Hello from the future, which is still your past. I was watching this back and I noticed that I missed canceling the 5 and the 15, which would also cancel with the 21. I made this problem way harder than it had to be after this. Went on for minutes with lots of multiplication and division. But I'm going to step in, interrupt myself, and finish canceling here. So the 5 and the 15 can both be divided by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And then the 21 and the 3 can cancel. Both can be divided by 3. 21 divided by 3 is 7. 3 divided by 3 is 1. Gives us 15/16 plus 7 times 1 is 7. 1 times 2 is 2. So much easier. It's always easier when we can cancel completely. Common denominator is going to be 16. That doesn't change the 15/16. 2 times 8 is 16, so we do 7 times 8 is 56. 56 plus 15. Carry the 1. 1 plus 5 is 6, plus 1 is 7. We get an answer of 71/16. Okay, back to me. Next. Next, let's take a look at, in parentheses, 1/2 plus 1/8. That's going to be squared minus 1/4 plus 1/8. So we have two groups of parentheses. One of them has a second power, one does not. Either way, we're going to have to work in the parentheses first. So adding 1/2 and 1/8, we're going to need a common denominator of 8. The 1/8 won't change. 2 times 4 is 8, so 1 times 4 is 4. To save some space, since this group of parentheses is a complete problem and this group of parentheses is a complete problem, let's just work on them both at the same time. 1/4 plus 1/8, common denominator is going to be 8. 4 times 2 is 8. 1 times 2 is 2. This 1/8 doesn't change. Finishing up our work in both sets of parentheses. 4/8 plus 1/8 is 5/8 minus, don't forget the square on the outside of the parentheses here, 2/8 plus 1/8 is 3/8. What does it mean to square? We have nothing else to do inside parentheses, so now we move on to exponents. 5/8 squared is 5 squared over 8 squared, which is 5 times 5 over 8 times 8. Not forgetting the minus 3/8. Next step, I'll write up top. 5 times 5 is 25. 8 times 8 is 64. And don't forget, we are still subtracting 3/8. We need a common denominator. It's going to be 64 itself. If you're feeling that I'm skipping too many steps, what I'm feeling is we did lots of work with common denominators in the past. You know how to do it. It might take you more time, but you have to be able to get these things, and your speed needs to start increasing. 25/64 is not going to change. To go from 8 to 64, that's times 8. So 3 times 8 is 24. Finally, 25 minus 64, or sorry, 25 minus 24 gives us 1/64. 1/64 is the final answer there. These aren't the type of word problems that we're saving for the end of the course. These are the type of word problems we've been doing already that just use addition, subtraction, multiplication, and division. The only new thing is that now the numbers are going to be fractions or mixed numbers. So here's our first problem. Joe and Mary Jones recently drove 317 1/4 miles on 13.5 gallons of gas. Calculate how many miles per gallon they got in their vehicle. If you need time to copy that down, please pause and then resume. So the key to the problem is that we know we're looking for miles per gallon. Miles per gallon literally tells us what to do. Miles per gallon. Miles divided by gallons. And what do we have? We have 317 and 1/4 miles. And the gallons of gas was 13 and a half. So here's the problem we're doing. 317 and 1/4 divided by 13 and a half. How do we divide mixed numbers? We need the improper fractions first. So 4 times 317. 8. Carry the 2. 4 times 1 is 4. Plus 2 is 6. 4 times 3 is 12. 4 times 317 is 1268. Plus 1 is 1269 fourths. Divided by 2 times 13 is 26. Plus 1 is 27 halves. How do we divide fractions? We keep the first. We change division to multiplication, and we flip the second. I'm going to write this in the top right corner so that I have more room to show you what's going on. (1,269 fourths) times 2/27. Let's cancel. 2 and 4 can both be divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. 1,269, 1 plus 2 is 3, plus 6 is 9, plus 9 is 18, which is a multiple of 3. So we can divide by 3. 27 divided by 3 is 9. 1269 divided by 3 is 423. 4 plus 2 is 6, plus 3 is 9. This can be divided by 3 again. That means we could have divided these both by 9 and saved a step, but that's okay. 423 divided by 3 is 141. And 9 divided by 3 is 3. I am going to treat you as if you know how to do everything from previous classes. That's why we do it in previous classes, and we don't just start with problems like this. And we can still go again. 1 plus 4 is 5, plus 1 is 6. So this can be divided by 3 again. 3 goes into 14 4 times. 3 goes into 21 7 times. 141 divided by 3 is 47. 3 divided by 3 is 1. We just have 47 over 2. (47 over 2 miles per gallon), or in a way that you might be more familiar with hearing, if we divide out 47 by 2, we get 23 and a half. So the other thing to say is 23 and a half. miles per gallon. So the key to that problem was realizing miles per gallon tells us miles divided by gallons. Our next problem. A total solar eclipse in 2003 lasted 4 3/10 minutes and was viewed from the southern hemisphere. The next total eclipse in 2005 lasted 2 2/3 minutes and was viewed from the northern hemisphere. There's a lot of information here we don't need, specifically where we were viewing it from, because the question is, how much longer was the 2003 total solar eclipse? If you need more time to copy, please pause and then resume. So this question is just how much longer? That's a subtraction problem. We take the big minus the small, and we get the difference. The difference is how much longer the longer one was. Since they tell us the 2003 one was longer, the 2003 one was 4 3/10 minutes, and we would subtract the other one, 2 2/3 minutes. Duh, 4 is bigger than 2. And now here we are, a problem that we did a lot of work on today. We need a common denominator. That's going to be 30. So 4 and some number of 30ths minus 2 and some number of 30ths. What is the number of 30ths that we have? 10 times 3 is 30. 3 times 3 is 9. 3 times 10 is 30. Oh no, 2 times 10 is 20. We're going to have to borrow, or we can use our trick. Let's do the trick first. Add 10 30ths to bump this up to the next whole number. Add 10 30ths up top as well. That's going to give us 4 19 30ths minus 3. So our answer is, it is 1 19 30ths minutes longer. Since this was a mixed number problem, we need a mixed number answer. 1 19 30ths. And we know the other ways to do this. I'm going to leave those to you to try if you want, but you're going to get the same answer. Next up, a good old area and perimeter problem. We have a rectangle. We have a length of 2/3 of an inch. We have a width of 5/9 of an inch, or width and length, really doesn't matter which. Doesn't matter what you call what. We're going to look for the area. We're going to look for the perimeter. We have to remember, how do we find area? Area is length times width. We multiply them together. 2/3 times 5/9. 10 27ths. And what's the units on that? Inches times inches is inches squared. square inches. 10/27 square inches. Now for the perimeter, we add the sides, add them all. Add all four sides. So that's a 2/3 plus another 2/3 and a 5/9 plus another 5/9. We have some common denominators. We don't need to find it all yet. 2/3 and 2/3 is 4/3. 5/9 and 5/9 is 10/9. But then we do need a common denominator, and that's going to be 9. So the 10/9 isn't going to change. 3 times 3 is 9. 4 times 3 is 12. 12/9 plus 10/9 is 22/9. And this one's going to say type a whole number, proper fraction, or mixed number. So 22/9 won't be accepted. We're going to have to divide to find the mixed number. 22 divided by 9. 9 goes into 22 twice. 2 times 9 is 18. Subtract, we get a remainder of 4 that goes over 9. And what's the units? Since we're just going around, inches plus inches plus inches plus inches is still just inches. So 2 4/9 inches. For our next figure, it's going to be the same type of problem, area and perimeter. We have a square. Square, all four sides are the same. And the side length we're given here is 12/19 meters. So you could follow the other formulas, length times width for area, add all the sides for perimeter, or you can use some shortcuts for a square. The area of a square is the side squared. So the area would be 12/19 squared, which is 12 times 12 over 19 times 19, which is 144 over. Have to multiply. 9 times 1 is 9, plus 8 is 17. 361. And it's meters, so square meters. The area would be 144 over 361 square meters. For the perimeter, you could add up all the sides, 12/9 plus 12/9 plus 12/9 plus 12/9. Or since you're adding 4 times, that's the same as perimeter of a square being 4 times the side. 4 times 12/19. 48/19. And when we divide that out, 48 divided by 19, we get 2 10/19. 2 10/19. And since we're just adding meters up, 2 10/19 meters would be the answer. two more very interesting problems, if you ask me. If you need time to copy it down, pause and resume. Charlotte has 12 1/3 feet of plastic pipe. She cuts off a 1.5 foot length, then a 1 1/4 foot length. If she now needs a 10-foot piece of pipe, will the remaining piece do? If not, by how much will the piece be short? So this is multiple subtraction and then answering a question. She's starting with 12 1/3 feet, and she cuts off, she gets rid of, she subtracts 1.5 feet. How much does she have left at that point? Well, I'm going to add a half to both. You know, different ways to do this if you want. This is going to be my default going forward. $12 1/3 plus 1.5 would be 12 and some number of sixths plus some number of sixths. 1/3 is 2/6. 1/2 is 3/6. This is 12 5/6 minus 2. She'll have 10 5/6 after the first cut. So I'm going to do it again. After the first cut, she has 10 5/6. Then she makes another cut. She gets rid of another 1 1/4. So I'm going to add 3/4 to both to bump up the second one to a whole number. So now this is going to be minus 2. We're going to have 10 and some number of somethings plus some number of somethings. What's the common denominator for 6 and 4? It's 12. 6 times 2 is 12. 5 times 2 is 10. 4 times 3 is 12. 3 times 3 is 9. So this is 10 and 19/12 minus 2. That's 8 and 19/12. We don't like that improper fraction inside the mixed number, so that's 8 plus and what is 19/12? That's 1 7/12. So this is 8 plus 1 7/12. That's 9 7/12. So now she has 9 7/12 feet. Is that enough if she needs a 10-foot piece? No, it's going to be short. By how much? Well, let's subtract. She needs a 10-foot piece, but she only has 9 7/12. I'm going to add 5/12 to both to turn the second one into what we need, a whole number. That's 10 5/12. 10 plus 5/12. Minus, the whole point of bumping that up was to bump it up to 10. So she's going to be 5/12 feet short. There we go. If Tucson's average rainfall is 11 3/4 inches and Yuma's is 3 4/5 inches, How much more rain on the average does Tucson get than Yuma? This is another subtraction problem. You need to copy it down, pause, and resume. Almost like this is an important type of problem, huh? Okay, I'm going to add a fifth. That's going to bump up the second number. If this is a confusing method, use one of the other ones. You should be able to understand it then. Adding a fifth is going to bump that 3 4/5 up to 4. Adding a fifth there means we need a common denominator for 4 and 5. That's going to be 20. 4 times 5 is 20. 3 times 5 is 15. 5 times 4 is 20. 1 times 4 is 4. That's 11 19/20 minus 4. 11 minus 4 is 7. 19/20 minus nothing. The whole point of using the trick. We have 7 19/20 inches. If we had the decimal 0.3, this is straighten that out a little bit. This is spoken as what? Well, we know our place value. Where does it end? It ends in the tenths spot, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths. Ends in the tenths spot. It's spoken 3. This is 3/10, which sounds an awful lot like the fraction 3/10. And that's because it is. So what we're going to do is we are going to convert a bunch of decimals to fractions or mixed numbers. And then we're going to make sure our answer is completely simplified. Next. 0.11, tenths, hundredths, 11 hundredths. 0.5, tenths, 5/10, which reduces to 1/2. 0.15, tenths, hundredths, 15 hundredths. This reduces. They can both be divided by 5. 5 times 3, 5 times 20. 3/20. 1.51, tenths, hundredths. 1 and 51 hundredths. 1 and 51 hundredths. But watch this. This is also 151 hundredths. And when we convert this improper fraction to a mixed number, 151 divided by 100. Same answer. Yet more confirmation about improper fractions being the same as their mixed number. 0.016, tenths, hundredths, thousandths, 16 thousandths. This reduces because they're both even. Divide them both by 2. These are both even. Divide them both by 2. These are both even. Divide them both by 2. 2 over 125. This is how we convert decimals to fractions. More. 2.004. Tenths, hundredths, thousandths. 2 and 4 thousandths. 2 and 4 thousandths. This reduces. They're both even. Divide them both by 2. This reduces. They're both even. Divide them both by 2. Two and 1 2/50. More. 14.402. Tenths, hundredths, thousandths. 14 and 402 thousandths. This reduces. They're both even. Divide them both by 2. $14 and I'm checking this one just to be sure. 14 and 201 500ths. I didn't think it reduced, but I wanted to make sure it'd be accepted. I haven't been checking this. I've been really confident until now. $0.4002. Tenths, hundredths, thousandths, 10 thousandths. 4,000 to 10 thousandths. They're both even. Divide them both by 2. 2001 5 thousandths. $349.85 tenths, hundredths. 349 and 85 hundredths. We literally just say the number like we practiced way back when. And 85 hundredths. And we write it as a fraction or a mixed number. Whatever is coming out of our mouth when we say the decimal properly, that is how we write the fraction or the mixed number. Then we check and see, can we reduce this? Yes, they both divide by 5. But what is 85 divided by 5? I don't know, let's do it. 5 goes into 8 once, subtract, bring down 5. 5 goes into 35 7 times, evenly. So this is 17, and then 100 divided by 5 is 20. 349 and 17 20ths. We're going to go the other way now. Now we're going to start with fractions. And we're going to write them as decimals. Well, obviously, this is 0.5. And by that, I mean 5/10 is 1/2. And 1/2 is 0.5. But surely there's some math behind that, right? Well, let's start by looking at fractions that have those numbers we kept putting when we went the other way. 10, 100, 1,000, 10,000, so on and so forth. 5/10, because it ends in tenths, we're able to just go, okay, tenths. And then what's our number? We'll write it in ending there. 5. There we go, 5/10. We're only going to be able to do that with numbers that have a denominator of 10, 100, 1,000, so on and so forth. So let's take advantage of this while we can. 26/100. 26 hundredths. Hey, hundredths. Decimal point, tenths, hundredths. Fill in the number we have so that it ends in hundredths. 0.26 or 0.26, they're the same thing. This time I'm going to leave a little bit of room after my equal sign because we're going to need it. 83/10. We can still use our trick because we have tenths. But this is an improper fraction, so we would be expecting a mixed number. We would be expecting something greater than 1. There's going to be something to the left of the decimal point. So we're looking for tenths. Identify tenths. Tenths. Write the number so it ends in the tenth spot. The 3 has to end there, which means the 8 gets pushed to the left of the decimal. 8.3. That's the easiest way to do it. But if you went to a mixed number first for some reason, that's okay. 83 divided by 10. 8 times 10 is 80, remainder 3 tenths, 8 and 3/10, 8 and 3/10. So you'll still get there. But it's easier to just think of it as 83/10, the number 83, ending in the tenths place value. $853 thousandths. Hey, there's another one of those place values. Tenths, hundredths, thousandths. We write the number 853 so that it ends in the thousandths spot. 0.853. Be careful. Remember, we want to write it so that it ends in the spot we want. 3 hundredths, tenths, hundredths. We want it to end here, but we still have the tenths place value. What do we put there? 0. So 0.03 or 0.03. You don't need the 0 to the left of the decimal point, but you absolutely need this 0 here to hold the place value. 0.3 would be wrong. That would be 3/10. 0.30 would be wrong. That's 30 hundredths, which is again 3/10. 0.03 is what we need. 9,256 over 1,000. 9,256 thousandths. It's improper though, so we're going to expect something to the left of the decimal point. But let's identify thousandths, tenths, hundredths, thousandths. We write the number 9,256 ending in that spot, which means the 9 gets pushed out to the left. 9.256. $29 over 1,000. Decimal point, tenths, hundredths, thousandths. The number 29 ending in thousandths, a 0 for placeholder. 0.029. $578 tenths. It's improper, so we're expecting something to the left of the decimal point. Tenths. The number has to end there, which means the 57 gets pushed over the decimal point. 57.8. 57 and 8 tenths. Seven tenths. Tenths. The number 7 ending there. Remember, I said we like that. That's a shortcut. I'm avoiding giving you the long way as long as possible. 14/25. Well, there is no 25ths decimal spot. Decimal literally means power of 10. Is it time for the long way? No. What? Why not? 25 might not be a nice number, but it's nice enough that there's an equivalent fraction with a nice number. When we have 14 over 25, we can recognize that if we multiply by 4 over 4, if we multiply 1 and not change the value, 25 times 4 is 100. So 14 times 4 is 56. We get 56 over 100. Don't reduce. We want to turn this into a decimal. We reduce, we're just going to get 14/25 back. That doesn't help us. We're going away from that. 56 hundredths, decimal point, tenths, hundredths. The number 56 ending in the hundredth spot. Let's see how long we can use this workaround to turn it into the nice power of 10 trick before we have to learn the long way. 3/4. Do we have to learn the long way? Well, the question is going to be, can we multiply 4 by something and get one of our nice numbers? We sure can. We can multiply 4 by 25. To keep it equivalent, we would multiply the top by 25 because 25 over 25 is 1. And we get 75 over 100, 75 hundredths, tenths, hundredths, the number 75 ending in the hundredth spot. 0.75 is 3/4. Hey, maybe you knew that one. You got to know the math. 3/25. We can use our trick. 25 times 4 is 100. So we do 3 times 4 is 12. 12 hundredths, tenths, hundredths, the number 12 ending in the hundredth spot. If I'm going too fast, feel free to pause, catch up, pause and try, see if you're right. 13/5. Can we use our trick? Yeah, we don't even have to go all the way up to 100. 5 times 2 gives us our nice number of 10. 13 times 2 would be 26. Improper, so we're expecting something to the left of the decimal point. Tenths. The number 26 ending in the tenth spot. 2.6.